Good morning, good afternoon, good evening, everyone. Thank you very much for joining us today. I'm glad you could be a part of today's presentation, all about Eliza loudspeaker system design. Today we have an expert presenter, actually a pair of presenters. First coming to us from very sunny Berlin, Martin. How are you, my friend? And Martin, your mic, I believe, is still muted.
Scott, hey everybody.
Hey.
Yeah, I'm transmitting here from lovely sunny Berlin. Sorry, Tommy, to steal your phrase. We have blue sky and sun is coming out. And I'm very excited to talk to you about Eliza sound system design today.
Excellent, Martin, and thank you for joining us. You are one of the experts here at L-Acoustics all about Eliza and Eliza sound system design, and you're going to present some of the design concepts and practices for how to do this in sound vision, along with Sergey coming to us from London, correct?
Hello, everyone. Good morning, good afternoon, good evening. I'm very happy to join Martin today and help him or assist him presenting. I won't be able to moderate today and answer questions in Russian, but I hope you will enjoy what you will see on the screen today.
Excellent. And Sergey and Martin, you guys are going to go through a bit of a presentation and then a bit of hands-on with sound vision on how this design process works. To help moderate questions in German, Spanish, English, and French, starting out with our German friend in sunny Berlin. Tommy, how's everything in sunny Berlin today?
Big surprise. It's sunny in Berlin, like Martin already told. So the second Berlin guy. Hallo liebe Freunde da draußen. Wir versuchen wieder eure Fragen auch auf Deutsch zu beantworten. Martin wird unter Umständen auch das ein oder andere natürlich schon erzählen, aber er macht es auf Englisch, weil er quasi der Präsentator ist und ich versuche euch auf Deutsch zu antworten, wenn dort Fragen sein sollten. Back to Scott.
Thank you, sir. And let's go ahead and head slightly west of there. I think our first stop is just outside of Lyon. Arno, how are you doing, sir, today?
Hi, Guy. Hi, Scott. Hi, everyone. Hi, Martin, Sergey, Tommy. Nice to have you all with us. I will be answering your question in French. Bonjour à tous. N'hésitez pas à poser vos questions en français. J'essaierai d'y répondre.
Excellent. Well, thank you for joining us, sir. And Marcus, coming to us just outside of Los Angeles in Thousand Oaks, California. Marcus, how are the guitars today?
The guitars are going well. Everything is great. I'm glad to be here. Glad to help out with the presentation. Really excited to speak about Eliza. And se puede hablar en español también. Good morning.
Cool. Well, thank you very much. So I'm going to hand it over to Martin, who's going to share a presentation with us. Martin, so you're going to talk today. Whenever you're ready, you can share that presentation on the presentation here, the webinar here. And voila. What we've got here is Mr. Martin starting out.
Hello.
Yep. There we go.
It seems that I'm dropping off, so I hope this connection will be stable. Is it fine at the moment?
Yeah, it seems good. It seems great.
Okay, cool. All right. So what we want to talk to you about today is a bit more detail on Eliza sound system design. So I hope that a lot of you have followed yesterday's presentation by Scott. Which was a global overview on what we call internally the full system approach, meaning that there is a very high interdependency between the different columns that make up a complete Eliza system. So you have the mixing tools, you have the processing, and of course you have the sound design, and all of that is highly interconnected. And that's, of course, a reason that a company like L-Acoustics, who wanted to deliver an approach for this, had to think about everything as one package. Because if you don't do that, there's no way to come up with something that is reliable or predictable or even repeatable. So even if we go today a bit more into the sound design topic, I'll ask you to keep that in the back of your mind. So what do we want to share with you today? So we like to recap a bit of what Scott did yesterday, do some considerations of what is the benefits of an ELISA system, also going through the different elements that make up a system, so defining which parts are there, which are the roles of it. And from there, we like to take it to real-world use cases, which Sergey and I will present to you, just to give you an idea of how these elements will play out in real-world conditions, and also to show you some of the considerations that you do by designing such a system, and yeah, the tools that we have in Sound Vision to help you making good decisions. And of course, it might be a good, interesting question in the end. Sergey will focus on that a bit, to compare what is a ELISA system in comparison to a conventional system, just in terms of speaker count, budget, and performance. So just to round it up a bit. So I'd like to start it with recapturing a bit of Scott's part yesterday. What is the reason to go for an approach like ELISA? Scott told us yesterday that one of the goals that we want to achieve with ELISA is to create something that we call hyperreal sound. So what is hyperreal sound? If you regard this from a listener perspective, hyperreal sound means we put a large amount of the audience in a situation where the things that they experience is highly credible and highly transparent, and also matching what you see on stage. And this listening experience is, from listener's perspective, really relaxing, so you can connect to what's going on stage, because your brain is not as busy to compensate things that might not be correct, so from your perception side. And Scott talked about that yesterday a bit. And from an engineer side, how is that achieved? Well, it's basically two things. One thing is that with the system design approach, we're eliminating or dramatically reducing some of the nasty side effects and artifacts that we are used to live with for decades now, that are coming from the way how we usually traditionally do our sound systems. And finally, I mean, we're just used to it, but that doesn't make the things right. Finally, we are more or less correcting that with the ELISA approach. And the second thing is that we come up with something, we're introducing something to the live world, which is a mixing tool for the mixing people, and that is pan. So panning has been there for a long time, but it was not available for us as live people because of the large scale audio. And maybe because there were a lot of questions about this topic yesterday, just follow me through a small consideration walkthrough through what does the system look like today and what is the things that happen out of that. So let's assume we're sitting in a sweet spot. That could be at home, that could be in a large area, arena, wherever. We know that we can, in the sweet spot, we can use panning to place stuff between two speakers. And so we're basically creating a phantom source where there's no speaker, and we have a real source where there is a speaker. And this is working quite well when we're in the sweet spot. Unfortunately, we know that the sweet spot is a very small spot and it will not scale up. Even so, when you're at home, the sweet spot that's coming out of a speaker system that is distance of 3 meters, then this will not scale up when you go larger. So in this case, we have a a scaled-up system with a distance of 20 meters, and the sweet spot will have exactly the same size as at home. So that's bad, and we all know this very painfully from our experience in the live world. So if I would mix from there and I would have an idea where to place my stuff, I could come with, just as an example, place my drums in the middle. So this will create a phantom source here in the middle. I would pan my saxophone on hard right, and I would place my guitar half left. So when I move out of my sweet spot, we know that everything that will not be hard panned will follow me. So if I move a bit to the left here, then you see that everything that wasn't hard panned follow me, and it will eventually end up in the left speaker. So now we put those two elements on top of each other, which will get us some trouble in our brain to make them separate again. And of course, they are not anymore in the right location. But and that's what we use from our home stereo system. If you move around in your living room, that's what's happening. But in your living room, you don't have any visible representation. So it's not as dramatic as here, where the drum is still in the middle, even if you hear it from the left. But then in our live situation, there's another thing that might happen, because we all know that if we move closer, we have a situation where you might get out of the coverage of one of the speakers. So whatever you have put in here, you see that now we are very close to the left speaker, and the right speaker is a bit far away, and we are not in the coverage of that speaker anymore. So what is panned to the right is probably much more than 60 dB down compared to this. So when you're sitting here, you will not follow the saxophone anymore too much. And that's, of course, not acceptable for us as mixer. And that's the reason why we mix in mono in the end, in dual mono. Meaning, by creating a mono mix, we reestablish the full mix in mono for this guy, which is fine. I mean, we just packed everything together, but at least we have a full mix. But what will happen when we move back? When we go back to our second position, you see that now with the dual mono approach, we have the same information twice. And I mean, repetition is probably a good thing for training or webinar, but certainly not at 20 milliseconds delay. So this is really decreasing our sonical quality in here. And I mean, the value of 20 milliseconds, you can imagine that that's the typical value for choosing a pre-delay and a reverb. It's something that you use for delays to create spatial things, so to make your sound a bit spacey. And so this is done by accident here for all our overall mix, to create spatial stuff that we didn't want. So, and it's really decreasing the intelligibility of stuff. And to be honest, this 20 milliseconds is still a moderate value. So you can imagine from other geometrics, other venues, it could be more. And the other thing that comes with 20 milliseconds delay is also that you have a lot of interference, especially in the low end. So you will get power alleys, power valleys, a lot of this stuff that you try to reduce usually in your sound design. We all know that this will get better when we go back to our sweet spot. So the difference in delay will come back to zero. And so if we use some tools in Sound Vision to map that and to try to change a bit to define which is the role here, you see that we have a yellow area over here that is more or less the region where you have only one array, and the other one is dropped by at least 6 dB. So that's fine. You have only one. And this dark green area here is where you have this spacey conditions. And the light green is where you are experiencing both arrays, but they are already within 10 milliseconds of arrival time. So you have reestablished a quite good sound quality, and yeah, just by doing that. So still, you see that if you look at the percentage over here, if you have the percentage over here, you see that this dark green area, which is really the bad one, that is around 50% of the audience. So meaning we are really doing like 50% of the audience in a spacey zone. Is that really what we do? So maybe there's a better approach. So what is our idea here? What can be done against it? Well, let's go back to our initial idea of placing elements. We wanted to have the drums here in the middle, so why not put a speaker there? Because then we only have one speaker. There's no interaction between two speakers. This will be perfect sound. We have also, for everyone in the audience, the right localization of it. And yeah, so that's pretty fine. We say at L-Acoustics, the best sound comes from one source in the right place. The only thing that you have to consider here is it's quite important that you have a large coverage of that speaker, because you see, this is the definition of coverage, meaning this is a system that has 110-degree opening angle, and this is displayed here, because the coverage means that you have on axis a reference level, and you move out of the axis until you reach -6 dB, and that's your coverage. So everybody in this yellow area will have this drum within 6 dB level difference, which is fine. So having this beneficial wide horizontal coverage is why we see a lot of K2 systems, a lot of Cara system. A10 is probably also a very good choice. SIVA systems if you have less requirements. All right, so this is a good solution. This is real mono, but we wanted to have some other instruments here. So our saxophone was already hard panned, so there's also no interaction on this. But we see that by the position of this array, we are not covering everyone. So if we would imagine something like a left, center, right system, we still would not be able to pan this hard right because this guy is not experiencing it. So the solution to that would be to turn the speaker in. So now he's back. So now you already have a drum set and the saxophone, where we both have brought everybody here in the covered zone, so that everybody can experience the right location and the full sound of each instrument. What is then the next step with something that was placed as a phantom source? That was the case with our guitar. Now we already have introduced this left, center, right system, and you see that halving this distance between the left and right already increased our light green zone here, which is already a good thing. And from the localization point of view, I mean, you know that when you're sitting over here, the guitar will follow you, but it will only follow you until here. So it's really caged between those two arrays. So it's already better. It probably could still be improved. Why don't we just put another array in between those? And you see that by doing that, for this element and for anything that is panned between those speakers, we can reestablish a very good sound quality on the complete audience here, or at least this large zone. We eliminated this spaciousness out of the signal, and also from the localization perspective, this can only spin out of up to here or there. So anybody who's sitting here will just have a very, very small deviation from his perspective compared to what was meant, what was tried to achieve. All right. So from this example, I mean, the performance zone here is around 20 meters wide. And you see that with 5 arrays, we can guarantee that we have a good sound and a stable localization. So that's quite easy to understand, I hope. And that's where we start with an ELISA system, actually. So let's have a quick review through the different components of a typical ELISA system. So what we just talked about is, in our terminology, is called a scene system. So it starts with 5 full range sources, as we just saw. Depending on the performance zone, it might be more, but it's starting with 5. And those are linked to our performance zone. So this gives you the possibility to place stuff that you see, also make the connection to what you hear. Of course, as we saw already, it is quite important that the coverage of all those 5 speakers are overlapping. So because that is assuring that wherever you sit, any panning decision by the mixing guy is valid for you, and you can still experience the full sound of it. So that's what we just walked through. That's the scene system. Now, depending on the circumstances of your project, the scene system might look a bit different. So we'll talk about that in our use cases later a bit, because you might have shows where there's more SPL target needed, where there's more low frequency contour needed. And also you might have a very large performance zone where you need more frontal speakers. And from this low frequency contour requirements, we derivate 2 different design options. So the first one, which I will later on present you in a use case, is a wide design, where you have at least 5 identical, evenly spaced sources. And if your show is really low and demanding, we came up with a pragmatic approach that we call focus design, where you see that we enhance the central 3 arrays with something that is more low-end capable, and also put them a bit closer together. Now, Sergey will drop a bit more words on this, but the idea of that is to give the capabilities where they're actually needed. So still with the freedom of pan, there will be aesthetic reasons to mix your bass drum not on the far left. It will end somewhere in the middle, where it combines also with the bass guitar and so on, and you get a lot of punch out of the middle. So that's the basic approach with a focus design. And also this approach will work very well together with what we have with our sub. So subwoofer in our game is a centralized subwoofer, as Scott already told you yesterday. So we like to have this centralized because that is very efficient. If you put all the subs together in one place, it's the most efficient way of doing it. And having it flown will provide a very good homogeneity. So you're not blowing away the first row while there's nothing left in the last row. So you can have a very good SPL distribution out of the subwoofer. The way we drive the subwoofer in ELISA is we generate a mono down mix in the processor. So this will be automatically generated in the processor. You can, in the ELISA controller, define what has to go in there, but it's basically, usually the scene systems. So all of those 5 arrays will sum up in the subwoofer. And you see that's for that reason, it's very good to have the focus design where everything that is working together in the low end is really close coupled. Then we have sometimes it's an option when you can build it in, or if you can afford it. We have extension speakers that are there just to give you the option of placing all your elements in the mix, that making your mix wide. I mean, usually you have some elements that are clearly visible on stage, but you have some things in the mix that's purpose is to make things wide, like reverbs, delays, keyboard pads, and all that stuff that you don't really see on stage, but yeah, will expand your mix. And to give you this extra panorama, you can put some extensions in. The strategy here is, again, to aim then to overlap with the spatialized zone, so that everybody can experience that. And then the last step for a frontal system is that whatever you do with the sounds, with the design, you will not be able to cover each seat with each array. So you will still have some seats, like in my small walkthrough with this first row seat where you miss the saxophone. And to reestablish the full mix, we have to bring in some fill speakers. And those fill speakers will also be driven by a mono-down mix or a separate aux send. And it's only there to reestablish what's missing in that area. And you can imagine that by putting a mono signal in here, you don't want to disrupt what you created in the spatialized zone. So you have to be careful in the design process not to overdo this with the fills. But it's an essential element to make this happen in the front rows. All right, so this is what we call a frontal system, all those together, because it's only frontal. And that's creating hyperreal sound, what we just discussed. So you have a very high resolution in the front. You get this natural separation of stuff. You also have the possibility to pan something on a speaker, meaning that is the best close sound that you can get. And this, especially maybe tomorrow when we have a small session on the mixing side, this might be interesting to go into that you have now the possibility to pan things on speaker or between speakers, which is a bit a mixing choice to have things really cut through or blend a bit more with other elements. And yeah, you create the connectivity from what you see is what you get. And not to forget, we have some creative possibilities here. If I'm the mixer, I now can pan stuff. I can make movements. I can have dynamic things like expanding the verse and making the chorus small, or the other way around, whatever. So there's a lot of things that I now can use that wasn't possible before. But it doesn't stop here. We can expand it also in the 3-dimensional domain by placing additional stuff like surround systems. Now in our approach, the surround speakers are also driven with discrete signals, because that gives you the possibility to really have a good trajectory in this lateral domain. And of course, you can expand that also in the 3rd dimension and have overhead speakers, where you also have discrete signals. So meaning with all that, you already need some amount of outputs, but luckily our processor can generate 64 outputs, so that's not a problem. And we create with that something that we call immersive hyperreal sound. And we have a lot of use cases where we have used that, for example, domes on EDM festivals and creative stuff. And also it's very popular on, this sort of modern art, interactive video arts, where you have immersive video and immersive sound that really works very well together. And it's really fun to walk into that. All right, so this was a quick overview on the tools. Let's get out of this presentation and start with a bit 2 use cases on that I will show you on sound vision. So hopefully you see my screen with the sound vision here now. As I don't get any protests, I think that's true. So my first use case, and both use cases we're showing to you is to Frontal systems. My first use case is a concert hall and performing arts center. It's holding around 2,000 people. And yeah, so you see somebody already had done a nice simulation, a nice room model, which is of course key to do a right sound design. But to start a design, you have to do the same things as you usually do with any design. You have to collect some basic information. So room model, then of course you have to get the ideas of where can I hang my speakers and so on. But one of the most important stuff that you have to consider is what is actually the program that will be running in that venue. And in this case, we have a really wide variety of stuff. So it's 80% something between stand-up comedy, unreinforced classical music, some reinforced classical music, jazz music. So that's the 80% of it. And then occasionally there are some gigs coming in that are a bit more demanding in terms of level and low frequency contour. And so you see, you have to make a consideration to find the right system and also to make a design choice if it's a wide design or a focused design. And to help you with some basic information, we have created a small tool that is called ELISA Loudspeaker Layout Configurator, which is more or less just a summary and doing some math for you. So we have underlaid some best practice values that we found that are really helpful and to have at hand. That gives you some proposals which might be fine what's your goal to achieve. So for example, if I have my program speech here, you see that I would probably need a system that would be capable to deliver 99 dBA with just a very small low-end contour. And if I change that for jazz, which would be the standard choice in our venue, you see that it might be a good idea to have at least 102 dBA on SPL maximum average over the audience, with a bit larger contour on 100 Hertz, but it's not really massive. So we are not talking about heavy rock in this venue. We're not talking about EDM stuff. It might be a bit more demanding. So we have this funny category here. So you see that this is maybe something we have eventually, and where we have the proposal to maybe think about a focused system. In our case, it was decided to have a wide system design because that's what we usually have in the venue, but to have at least the capabilities from the SPL capability and also from the low-end capacity to handle something that is more demanding. And of course, you know, when you watch these other webinars that we have the contour filter, so you can easily adjust the low-end contour of a system by using that. Of course, assume that you have enough headroom to do so. And that's what we have to care about here. So what is also coming out of this, you want to have 105 dB in total, but as we have with a scene width of only 12 meters, it's proposing to have 5 scene arrays. And if we are, because we are spreading those 105 dB on 5, the single array of those needs only to be capable of 98. So we don't have to have 5 arrays of very large capacity. It can be reduced because we are spreading our energy. Okay, so that gives us a very easy information that we can use as starting points, and of course then it's a question on the fly what's needs to be changed. All right, let's quickly start. So the first thing here that I've prepared is usually you would design your center source in the way we saw in other webinars, so I'm not going into this. You see, the choice was made to use a Cara system. If it would only be the jazz stuff, probably it could have been handled with Kiva, but for having this low-end capabilities and also the benefit of 110-degree opening angle, it's very beneficial to have a Cara system here. And you also see that we have to cover with this system quite a large vertical area, so it's ended up with 10 Cara installation series here. Now, probably a lot of people have already asked yourself, why is my sound vision looking different than yours? And what are these things about? Now, this is due to, I've unlocked a thing that is called Elisa Feature Pack on this version. It is included in every sound vision, but you have to unlock it. So that's the bad news. You don't have it in the moment. But the good news is you can have it. Because we have a training series on Elisa topics, which we regularly hold. And it's a 3-day training. And the sound design will be like one afternoon of it. So sound design and sound vision. And when you have participated in that training, we will unlock those feature pack for you. Of course, in a webinar, we only can scratch it a bit, but hopefully you get an idea of what the tools are for. And then I hope to see you in one of those trainings to get a bit more into the details. But basically, we are introducing a new mapping mode, which is called quality mapping mode. And that's multi-mapping. So meaning it's calculating different mappings in one step. And also those things are different mappings that will provide us with some additional information on things that are really about the hyperrealism, the performance and that. And so that we really can investigate on different things. Now let me quickly run this. And you see that now we get our yellow color that we already seen in my slides. And this yellow color means that we are only having one source. So we're looking at the coverage of this source. Probably there will be some sound over here, but it's outside the nominal coverage of that. And the reason to reduce it to this nominal coverage is that later on we're using this tool to find the best overlap between speakers. So it would really be distracting if we don't have this clear borders. It's still unshared because we're not sharing with any other element. Pretty boring yellow, but let me show you some very powerful thing. Up here is a window that displays a summary of our quality mapping results. So everything that's in different mappings will be included in a summary here. And the great thing is that you see percentage and values. So that will help you in the design process to make decisions, because everything that you do will be reflected in real time here. And you see, when it's easy to understand, 100% is better than 50%. And if you see that you're moving in the right direction, then you have a good choice. And if you're moving in the wrong direction, then maybe reconsider it. And the other thing that is really powerful about that, you have a summary of things over here in percentages. You can use that also to communicate to people that are non-audio. I guess all of you have had this discussion with people from production that really are non-audio, and you have to convince them of whatever your need is. And having numbers and mappings for that is a great thing to have. So for example, if I want to convince my production that I could need a pair of extension speakers, it's very clear. You can show how much percentage of the audience will benefit from that. You can see in the mapping which seats are benefiting from that. So if you have, you can tell them, look, this is the area where you wanted your VIP people to sit. And if you add those speakers, it will cost you about this, but then your people will be very pleased. So that's something people in the chain of command can work with. It's better than just coming to them and say, I know that it's better somehow. So this is really something where you can rely on in a conversation. All right, so what can we use in this case already? You see that we have achieved with this array only an SBL max average of 100 dB, so that's enough. We were targeting for 98. Now with this large vertical coverage, we are already at 100. We also get a very good SBL distribution, meaning from the loudest point to the quietest point in the audience, this array is just dropping by 6 dB, which is very good. And the rest of those will I will explain a bit later. So probably that's a good way to go with our central array. So I have some copies of that placed in the right position, which our loudspeaker configurator had proposed here. And if I bring in the next one, you see that we create now a shared zone between those two. So everything that's light green here is the shared coverage between those two speakers. You see that there is still something yellow in the bottom here. That's where you only have one of both speakers. And you also get a percentage of that. So we share 97% of the audience between those two areas. And this value is very handy because when trying to find the right azimuth to turn it in, you can just watch it. For example, if I turn this out, then you see that we are not covering with this speaker anymore here. So we are losing shared space. And so we're now down to 92%, while it was at 97% before. So that's very easy. You just try with the azimuth until you reach the best value, and that's it. All right, so let's quickly unhide our full system and have a look on the other indicators. So this is how it looks with everything involved. You see that there are still some completely missed areas. There are some areas where we will need front fills to reestablish the full mix, and also under the balconies. Probably this edge is blocking some of the speakers, so in the end we will find some fill speakers for addressing this. But on the other hand, you see here we are reaching everything. That's fine. Okay, so now it's the time to talk about these percentages, because you see that has changed when I brought in the other things. So what the hell is horizontal localization of 85%? Well, we have a mapping for this, which looks like that. And the idea behind that is just to do what we did with our guitar. Remember, if I want to place my guitar in here, I can calculate from each point of the audience. It will move maybe to this point from this perspective. And I can calculate how much degrees is that moving. Of course, from here, the possible error of what I was trying to achieve and what's perceived is very small. So that's only 2 degrees. While in the front row, it will be larger because the spacing perceived from here, this angle is then larger than from back here. So we can precisely calculate how much the maximum deviation of something that was meant to be in the middle is on each seat. And our goal is, for the hyperreal approach, to achieve something that is has less deviation than 7.5 degrees. And this is the dark green zone in this mapping. So even also 15 degrees is still fine, but this is the optimum. And we calculate simply this area on the total ELISA zone, and that's 85% of the total ELISA zone. So that's a really good value for such a venue. We can do the same with the vertical localization. So if I go over here, in this case, we have to have a reference position on stage. So we're assuming we have, I guess that it's hard to see here, there is a red dot on this line. So this will represent my singer maybe. And of course, you now can imagine that from this perspective, you have an angle, you're seeing it here, you're hearing it from there. So there is a deviation in the vertical domain. Luckily, we are not as sensitive in the vertical domain as in the horizontal domain. So our goal is to have less than 30 degree. 45 is also still a very good value. And of course, for the people in the front, the sound will be a bit up in the sky, but remember, we'll also have some fill speakers here, and there will be some direct sound from stage that makes it acceptable. Yeah, and then the last indicator here is called panorama, and that is, in my example, not very high, so it's only 21%. And why is that? Well, because panorama is from every seat in the audience, what is your maximum opening angle between the left and the furthest right speaker. So of course, when you're in the back row, this is only 18 degrees, while in the front row, you'll probably have more than 90 degrees. So we are aiming for something that is more than 40 degrees. But of course, the only way to achieve that for this area of the audience is to have additional speakers to left and right, which would be extension speakers. And well, in our case here, unfortunately, we have sidewalls, so there's no way to hang extension speakers. But even without extension speakers, I can assure you this venue is sounding really good and has a lot of you have a lot of fun in there. All right, so you see that we have a very good summary, a very good tool to quickly make decisions on your sound design. But it's not stopping there. The next element that I had introduced in the slides was the sub. So let's have a look at the sub. I was telling you that our idea is to have a central sub flown over this above the stage, meaning a very good position would be on top of the main array. Unfortunately, in this venue, there was no clearance at all. So even those arrays are already up as much as they could. So there's no extra clearance. And also there was a proscenium behind it. So there was no way of flying it behind the main arrays. So the only way to make the central sub was to put it side by side in between, which is also fine because, I mean, the distance between those two speakers is quite close and it will couple very well. The big question will be, how many subs do I need for such a system? And well, the answer to that is, of course, you want to have the right balance in terms of level. And the other thing is you want to balance that in terms of headroom, because you don't want that you're limiting one of the system and the other still has capacities. And in this case, remember that these subs will be driven from the mono down mix. So all of these 5 scene arrays will contribute to what's driving this sub. So naturally, the headroom of this will be limited. And you have to make sure that you have enough speakers so that you can reduce your amplification level of the single subs. Just to give you an idea, we have some nice tools in Sound Vision to help you with that. Because when you see on my subs here, we have introduced a usage and a signal, so we can define for each element in my ELISA system, what is it? Is it a scene speaker? Is it an extension? Is it a surround? And in this case, fill and sub is both driven from the mono down mix, so we choose fill, and we use the signal all to tell Sound Vision that we are driving this from the mono down mix, which includes all 5 scene speakers. And you see, when I mute all my scene speakers, you have the typical resources that you will have from a sub. And because it's calculating how many speakers are contributing to this chain. If I mute my second one, see, we have an automatic headroom reduction, I would say, and our headroom is dropping here, just to show us that we are a bit out of the capacity balance, I would say. So that in the end, when we send 5 signals to that, we have 7 dB less headroom on this chain. And to keep up the desired level of contour, we might need to have enough subs. So that's okay. It looks like that's already the case. If I bring in a frequency plot that is made from this point, you see that with this, we already have too much sub. So I could easily go in my subs and reduce the level. So that's probably the level that matches it in a good way. So that will combine over here. And you see that now we have re-established our headroom on the low end to match what we have on the Karas. Yeah, so we could have also done to try to approach it with a small sub. So we have here something that is only 2 KS28, and if I unmute that, it could do the same, but we are limiting our headroom here, and we are also limiting by that the way our Kara system can follow, because if we can't turn this up completely without losing that. So this would be a totally limiting factor when we don't have enough subs in this case. So let's bring this back. Our larger sub is, oh, I muted the wrong one. Here we go. And you see, we regained our headroom on the Karas. Okay, I think the last thing to mention here is we were talking about fills. So we are missing some parts in the audience, and there's also some tools to help you align that. So let me quickly just unhide them, front fills and under balconies. And I'm
Martin,
yes.
Sorry to jump in. You've hidden one of the Kara arrays accidentally.
Thank you. Thank you very much. So to level align that, we have another mapping mode here, so you can see what your fill speakers are contributing to your level, and also there are tools to time align them, but that's probably too much into the deep, and I would say if you're interested in that, please join our training sessions. And that's pretty much what I wanted to show you on this use case. Before I hand over to Sergey to have a second use case with a focus design, I just want to mention that you can save your design, and then you can import that to your ELISA controller, so that from the mixing perspective, and that's also interconnectivity, the system knows where your speakers are. It can calculate it correctly, and it also represents some good workspace for your mixer that has something to do with what you see here. So that's really a very nice thing, and I guess that my colleague Frederic will tell us a bit tomorrow about that. So I think that could be a good transition to Sergey, isn't it?
Martin, can I ask you a question which might be useful for everyone? So in your Elisa configurator, loudspeaker configurator tool, you were aiming for the SPL, which was 105, I think. And you have a little bit more SPL capacity in the system, which is not a bad thing. But could you explain us why do you have more than you were aiming for?
Yeah, well, the thing behind that is starting with this the center array. You see that you have a very large vertical coverage, and of course you can achieve that level with less elements than 10, but you don't have a lot of choice on angles then anymore, meaning that you will have a very bad SPL distribution throughout the hall if you have to open up all of your angles. So to have a good SPL distribution, you have actually to cover that, you have to have more than you actually would need to reach your SPL. And I think that's a very common case for venues that have this vertical coverage.
Exactly, as long as you're above and not below the value. Of course, we are trying, when there is no need for the extra SPO, we are trying to stick to the targets because it's all connected to the budget as well. Budgets as well.
Right.
So Sergey, you bring up that budget. Is there a general rule, like how much more expensive is 3dB when it comes to overall budget? Is there a number for that?
Well, you mean generally, or you mean in the Elisa systems?
Well, so like in a regular sound system, if I were to double my subwoofers, I get 6 dB of output. And if I double my subwoofers, I double the budget of subs, right? So if I want a sound system to be 3 dB louder, that's 50% more expensive, if I'm correct. Is that my math? Is somebody double check me on that? And that's a really important thing for people to grab is if you over-design your system by just 3 dB, you've increased the cost of the system by 50%, right? So that's a hugely expensive 3 dB. If you over-design your system by 6 dB, that costs you 100% more, right? And that's speakers, amplifiers, rigging, cable, everything along the way. So 3 dB is 50% increase in price, generally speaking, and 6 dB is 100% increase in price, generally speaking, if you follow some design logic. So it's a really important thing to hit that number, as much performance as needed. But you know, when you see a sound system that can do 110 and you're mixing it at 102, that was a really expensive bit of headroom.
Yeah, exactly, and that's why I brought this question up. Is that with Elisa systems, we will talk about the price difference a little bit later in the presentation. But with Elisa systems, we've come up with this guidelines in terms of SPLs and genres which we are aiming for, because we need to be more mindful of the budget, so we are not overspeccing the system.
Great, thank you. I appreciate helping on that question. Back to you guys.
So Sergey, would you like to take over?
Sure. Let me find the right screen. I hope that you can see my screen with the empty arena with no one in it.
Perfect. Looks great.
Okay. So this example. Originally, this file was built with some project in mind, and then I just started to reuse this file as a generic template as a starting point. So this particular venue is Manchester Arena. For that particular project, we were aiming to cover most of the lower tier and half of the top tier because of the scoreboard. The scoreboard could be removed, I believe, in that venue, but I've kept it as a generic file, because if we hide, if we hide this, so generally the throw here, the distance to cover is about 80 meters, which is a good average size arena. So it's not the smallest, not the biggest, and it's probably good for the use case scenario. So what we have here, let me just unhide. We have the stage in its typical location. We have this area to cover, and I'm going to repeat some of what Martin said, but the purpose of this particular use case is to highlight the difference, mainly highlight the difference between the focus and the wide system. I will remind you, in the beginning, Martin said that there are two distinct types of the frontal system. One is focus, one is wide. The wide, ELISA wide frontal system is where the spacing, all the frontal arrays representing the stage, the scene system, all the arrays within that system are the same size, and the distance between all the arrays is the same. In case of the focus system, and I will unhide it here, the scene system of the focus system, we reinforce the middle three arrays in the low end department, and we change the spacing a little bit. We maintain the overall distance from array 1 to array 5. That would be the same with the wide system, but we change the spacing in the middle three arrays. So in terms of SPL, all the 5 arrays are comparable. Then they do not have to be exactly the same, but they are very close. They're probably within 1 dB. SPL 1 to 10K, the intelligibility range is going to be comparable, probably the same between them. Roughly, if we talk about K2 and Kara, the arrays of similar length will give you similar SPL, but the LF contour will be different. The coverage between them is also going to be the same or comparable. So the coverage of the center array, if I just solo that one and do a quick 1 to 10K mapping of the center array only. So this is the coverage of just the center array. Let me just change it here a little bit. And if I just go through the coverage of individual arrays, I will show you that they're covering more or less the same area, and they provide more or less the same SPL. So Kara is a little bit quieter in this example. What I've done in this design is I've kept the headroom of all the arrays to be close to 8 dB. If we look at the headroom, 8 dB here and 799, so the headroom is matched on all the components. So the weakest, so there is no weak component in this whole design which would limit overall headroom. So as I said, the coverage of the systems is matched. So we're trying to cover more or less this, no more or less this as much as possible of the same area with each individual array. We are trying to maintain the SPL. And in terms of tonality, obviously the K2 arrays will have more low end. And I will show you the tonality difference if I expand my EQ. So, okay, let's see. It looks a bit weird here. Okay, it's probably because of this values. I don't know why they moved. Just a moment. So what I will do here is I will type in the dmin and dmax value. For some reason, it's not letting me do it. I'm not sure what I'm doing wrong. Let me solo. Okay. I know why. Okay, just a moment. Let me hide this guy here. Okay, so I will select the scope of the middle half of the venue. So you can see this is the contour of the middle K2 array. It's around, so we are aiming for, if I go back one step, if I open the ELISA loudspeaker layout configurator. So for this particular example, we were aiming for the pop rock show. and automatically we have this target value of 105. This is a 105 dBA for the entire system. That's what we are aiming for. Obviously, that SPL max, that SPL level will be achieved with the contribution of the entire system. And from that number, we can derive the SPL of individual arrays. So we are only considering, in this calculation, we are only considering the frontal system or the scene system. So also we are assuming the signal is going to be uncorrelated. So the summation of 5 arrays is going to give us 7 dB of extra level of uncorrelated signal. So we know that each individual array needs to achieve 98 dBA. We can see it on the guideline here. So in terms of contour at 100 Hertz, we are aiming for 12 dB. It's not to say that this has to be this contour, but we need to allow this amount to be safe for the design. Then the eventual contour is going to be a choice of the mixing and system engineer, and based on what their preference is, but this is the guideline. So let me go back to the design. So this is the contour. In this example, I have it a little bit less at 100 Hertz, but it's close to 12 dB. It's going to be the same for this array. And if I go to the Cara array, again, I am looking at the same 40 meters of coverage in the middle to assess the contour, the half of the middle half. So I'm seeing that I match the contour as much as possible to about 80 Hertz with Cara. This is going back to K2. So we have mainly the difference below 80 Hertz between Cara and the K2. So in terms of the low end, that's one difference. The why do we need smaller step? And there is 2 reasons for that. One reason for the smaller step is that with ELISA designs, we have our recommendation is to keep subs in the middle, and I will unhide the subs for these designs. They could be 2 arrays, they could be 1 array, they could be 2 arrays in the NAND fire configuration, but generally we have our recommendation is to have subs in the middle, and these 3 arrays, because they will have certain energy which works in the same range as the subs, they will be physically close to the subs. So wherever we place objects in the system, they will be physically close to the subs. And this is actually when we start to come close to the ideal scenario of having all the low-end energy in the middle. Because even with conventional system, even with the centrally flown subs, we still have problems of interaction between left, right, and the subs in the middle. But with a ELISA system, all of the low-end energy will typically sit in the middle of the mix, be it kick or bass guitar, or something else which has the low end below 60 Hertz, for instance. So all the low end within the system will be physically closer together, physically in the middle. So that's one of the reasons why we have the spacing between the middle 3 arrays smaller than the spacing between the outer arrays. And the other reason is typically the rhythm section elements, say the drum kit. The drum kit, again, typically is in the middle in your mix. And if you imagine that you're on the side of the arena, some of the drums might be placed off-center towards this side, and some of the drums might be placed off-center towards this side. Or the bass guitar might be closer to this side, to this part of the system, and some of the drums might be placed closer to this part of the system. So we want to minimize the time arrival differences for the extreme left and right areas. Obviously, the spacing between the arrays depends on the venue geometry, on the scale, but also on the stage size. So this is a typical focus system for the typical stage size of 20 meters or so. In this case, in the configurator, I entered 18 meters. So we are not trying to match the physical stage necessarily. The physical stage might be bigger if it's a constant stage. We are trying to match the performance stage, the performance area. So the scene system is matching the performance area. And the step difference between this and this is logarithmic, and the formula for that is built into this configurator. But if we were to compare this focus design with the wide design, the outer arrays would be in the same place. So talking about the biggest and the smallest step. So as I said, the step is defined by the minimum for a laser system is 5 arrays. The step is defined by the stage or the performance width. So in this case, minimum is 5. It could be more, and it would be better if for the same spacing we had more arrays like 7 or 9, or a solid wall of speakers. But we have to be reasonable and with economics. So we have to be rational in our approach. So 5 is the minimum, and 5 is already a good step up from the conventional stereo system. So as I said, we are trying to be rational with our approach, because it will have impact on the budget, it will have impact on the time that is required to rig the system, it will have impact on the rigging, not always possible to fly more speakers, so there are weight limitations and so on. So we have to be rational, and we need to assess the return on investment, how much effort, how much money we are paying for to get higher resolution within the system. So these are all the things that we need to consider when we design the system. So the next step. So this is a basic laser system, which is the minimum requirement. And what I will do is I will run the quality mapping, which Martin has already used. I will go to the plan view. And quality mapping, as Martin mentioned, is a multi-layered mapping. So it maps all of these different things at the same time, plus all the all the laser-related metrics as well. I will click mapping. Okay, everything is muted. So for now, I'm just soloing the frontal system, not the frontal, the scene system, because frontal system will also include extensions if there are extensions. My computer is a little bit slower, 3 years old, but it's a very processing heavy process. So the green zone is what we call a laser zone, or in the quality mapping metrics, it's what is shown as shared align zone. So in this case, this is 88%. So the laser zone is 88% of the entire audience, which is not bad for the arena. And by clicking on the areas, we can see different SPL values. Maybe for the SPL, it's easier to switch to the SPL view, which is the A-weighted. Let me just do 104 here. So this is the SPL distribution of these 5 arrays and of the full range, or we can look at 1 to 10K distribution. So looking at the metrics here, we can see that we were aiming, going back to this calculator, we were aiming for 105 dBA, and we are getting 104.6, which is pretty close. Shared align zone 88%. Spatial resolution is simply, in simple terms, is how many frontal loudspeakers you have. So we have resolution of 5. It's like if we compare it to pixels on your phone, with stereo system we have 2 pixels to display beautiful sunset, and with a laser system with current configuration we have 5 pixels to display beautiful sunset. So 5 pixels is definitely better than 2. If we also take into account that 2 pixels are dual mono in case of the conventional system, then both pixels display more or less the same information. So, but this is just giving you perspective on the resolution. So horizontal localization, if I enable this mode, is the percentage, as Martin said, is percentage of within the laser zone showing the horizontal localization, which is actually deviation from if something was placed between the arrays, as Martin said, the guitar player stays here on stage, and we place in the mix, we place him somewhere here between the arrays. The horizontal localization from this point is going to be quite good, but as soon as we move to the center, the sound will snap to one of the arrays, depending on which side you go. So we are aiming for that deviation not to exceed 7.5 degrees. So if we click here, for that point, the maximum deviation from the maximum area is going to be 3.2. So the closer we come, the larger the area becomes, but still no more than 15 degrees. So this light green area, and obviously the closer we come, the more the area, but that area is generally covered with front fills. The vertical localization Martin explained, but I will give you a couple more things here. You can see this red square. This red square is showing us a reference point on stage, typically where the lead vocalist would be. We can specify, depending on the design, where that red point is, and this is the reference point in relation to which vertical localization is calculated. Basically, this is the angle. If I click here, from this point, the angle, vertical angle between the red point and the center array is going to be 14 degrees, which is less than 30 degrees deviation, which is good. That's why it's dark green. You can see the scale on the left-hand side, by the way, and that scale changes based on your mapping modes. And for panorama, panorama is basically how much you are immersed in the mix. Panorama is the angle between our two arrays. So this is the typical panorama. If you had conventional system, we would have more or less this spacing of 20 meters between the two arrays. So the panorama of this particular laser system is going to be comparable to the conventional system. If you look here, we are aiming to be more than 40 degrees, which is the dark green area. So if I click here, the value is going to be more than 40. And the closer we come to the stage, the better the panorama is. So the trend with panorama is the opposite trend to the horizontal localization. So light green, the value in the light green area is going to be somewhere between 20 and 40, 27. The further we go away, the less panorama we have. So if you imagine you are sitting in the back row of this arena, you will experience more or less the same involvement in terms of being in the sound. You will experience more or less the same as you would with conventional system, because it's the same width in terms of immersion or involvement panorama. As you come closer and approach this light green area, you can tell by looking at the system that you will be in the sound more. And as soon as you're in this dark green area, you will be in the sound. So, and this is where, if we are trying to improve the metrics on the panorama, we can see that we have pretty good metrics in all respects here, except panorama and spatial resolution. So this this indication here, the further from the center you are, the better. So parameter 4 is resolution. So this is 5. This could be better. This is basically, we have 5 pixels. We want more to be 4-star system. And with panorama, we are not doing great. Only 6% of the laser zone are in the dark green area. And the only way to improve it is to introduce extension speakers. So what I will do is I will unhide the extension speakers, which are here. You can see on the plan view. Quality mapping will have to recalculate to give us the results. And you can watch this panorama, parameter number 7, will change once the mapping is complete. We have to wait for several seconds. This is quite intensive mapping for this computer. And you will see that, come on. Now we can see that the mapping has changed. Now the entire area is acceptable in terms of panorama. with half of the area in the dark green zone. Well, half in terms of depth, but overall percentage is still fairly low. It's 24%, but it is already better than conventional system. Now, anywhere within this dark green area, we have more than 40 degrees of panorama. So more people will feel that they are in the sound. Of course, we are assuming that these arrays will not simply hang there, that there is some content to put in there. Like Martin said, it could be used for pads, it could be used for reverberation, it could be used for some effects. Something that is not necessarily present on stage, something that does not have to be localized to where the musician is. So we need to consider the content. And if there is enough content to place into the extensions, we can go for more extension arrays. One thing I would like to bring your attention to is that apart from improving the panorama metric, we have also improved SPL max average, because these arrays are also contributing to the overall SPL. So we have already gone just above the target, which is 105. And we have also improved the spatial resolution, which was 5, it's now 7. So we have 7 pixels on our screen. And if we wanted to go further and include the entire area into the good 40 degrees or more zone, we would include one more pair of extensions. So just to, while it's doing the mapping, just to explain and remind that extensions are not mandatory, they're optional. The minimum mandatory ELISA system is 5 frontal arrays. 5 scene arrays. So extensions are optional, but they are very highly recommended. Whether to go for 1 extension per site or pair of extensions total or 4 extensions, it depends on many factors like content. Do you have anything to place there in terms of sound, in terms of sounds coming from stage? Do you have budget? Do you have rigging? And we will compare the budget later on. Just to let you know, I have done these mappings previously on these files, and I have stored all the settings, so we will be able to compare it in an easy way without doing all these mappings again. We will be able to look at the summary. Now the entire, not the entire, most of the arena is in the good panorama. The number is 70, so 70% of this green zone is experiencing more than 40 degrees of panorama, and only 30% is experiencing panorama of between 20 and 40 degrees. So even by looking at the system, you can see that you will be in the sound in most of the seats. So the sound is going to be really wide. So in terms of spacing, you can see that the steps in the ELISA focus system are logarithmic. So the difference between the step between the middle 3 arrays and the next arrays is the same as the difference between this array and this, and then the following array. And that carries on further on. Obviously, there might be some rigging limitations or some walls, and you can see that I have raised the outer extensions. This is to manage the SPL bleed into the side. This is to keep the, even though the array is quite directional, we still have some low frequencies which are spilling everywhere. So I'm managing the SPL distribution by raising the outer arrays. And with extensions, we could be a little bit more flexible in terms of step. So if there are constraints, which we could go a little bit left and right. So this is the template and the guideline. So this would be the golden system for this venue, the golden frontal system. We are not going to talk about surrounds. That would make it platinum, I suppose. So this would be the golden system. Again, by adding two extra extensions, we've gained a little bit more SPL max average. Now we are 1 dB higher than the target, which is good, 106. This is based on the assumption that we are using all the arrays in a good way. So we are utilizing all the arrays well. And also one thing I did not mention is apart from the step, so you can see this logarithmic step, which is about 3 dB if we create an analogy in sound, 3 dB step difference. We also have 3 dB level difference. Ultimately, when you move the sound from the middle of the system towards the side, the sound should not change, the level of the sound. So we will match that gain, but the headroom capacity of this array will be 3 dB less. So the headroom on this arrays will be 3 dB less, which is typical because typically we will have less information on the outside of the system. So the focus system is patent pending system. I think this is unique only to us for the immersive systems. And you can visually tell that this is reflecting more or less this is reflective of what's happening in the mix. You will have more low end in the middle of the mix. You will have more information in the middle of the mix. You will have more density of content in the middle of the mix. And as you go away from the middle, your mix will become less and less and less involved. So this is the overview of the frontal. And the next one is to quickly have a look. Let me go out of mapping, out of quality mapping. I will only solo the center array. I will do conventional mapping. So this is the scenario of the lead vocalist. For instance, if you're only utilizing the center array in this as an example, we still need to cover all these areas. So in case of this area in the near field, we have front fields like we would with conventional system. And I will unmute those. So front fields will complement the coverage here, and we still need to cover these areas. So for that, we need the side arrays, and they would be similar to what you would have with conventional system. And what we are trying to do is to distribute this SPL. So in terms of signal, the signal is now correlated because what is going into the individual arrays will also go into the field system because it's driven with the mono mix down typically, or the auxiliary. Just to know that that auxiliary is not, if you are using auxiliary for the front field, it's not the console auxiliary, it's the auxiliary in the ELISA controller. And maybe Frederic will talk about it tomorrow during the seminar, I don't know. But there is an auxiliary within the ELISA infrastructure. So now because the system between these three is correlated, just to remind you, we only have the center array and the fields system unmuted. Because the signal is correlated, we have certain amount of COM filtering, but this is much less than with conventional system because the overlap between all these systems is minimized. It's like distributed mono system. In terms of level, similar to the subs, we need to take into account the summation of all the frontal arrays, and the outfields and front fields will need to be designed in such a way that they're capable of dealing with the accumulated level, the level which will be accumulated as a result of summation of all these signals. So it's all taken into account here physically. So you can see I showed you previously that the individual arrays had 8 dB of headroom, so 799 for the HF. And for the side arrays, for instance, I can do that. And I have 18 dB of headroom because I have attenuation of 7 dB here. And I have additional attenuation on individual arrays. So we actually have extra headroom available on these outfields. So we are able to raise them if required in level, but I do need this quantity of boxes to cover what is required. Of course, by bringing the side arrays, what I will do now is I will mute everything. I will mute everything and I will unmute the scene system. And I will unmute the side array system. And I will do a quality mapping again. Of course, by bringing the field systems, we will have certain influence on the ELISA zone, and we will see it in quality mapping. Of course, as Martin mentioned, we need to, when we design the system, we need to try and minimize the overlap to minimize the destructive interference. But on the other hand, it may look more scary here on the mapping than it is in reality. So what we see here is we see the green area, the yellow area, and the dark green area. The green area is the ELISA zone, which has now been reduced to 81% because we have reduced it by introducing the outfields. So we had ELISA zone a little bit wider. Now it's starting to merge with this mono outfields. But this is still a good number. So 4/4 of the entire arena will be in the ELISA zone. The yellow zone is the coverage, what we call unshared, meaning that area is primarily covered with the outfield, mono outfield. And that dark green area, in the metrics, it's called shared unaligned, but that may sound like a scary word. It's in simple terms, this area is the transition from the ELISA zone into the coverage of the outfield. If you imagine that you are in the venue, anywhere here, you will be in the spatialized ELISA zone. And when you move towards this dark green area, you will be hearing combination of the outfield, which is now highlighted yellow, and the frontal system within the range of 1 to 10K. And effectively, you will have multiple complex combinations of mono outfield and individual objects, individual sounds placed in your soundscape. And this is not mono experience, and this is not exactly a ELISA experience, but this could still be very, very good specialized experience. And as you move closer to the coverage of just to the yellow zone, which is qualifying as unshared zone, still, even though in Sound Vision show it as unshared, and not unshared is based on the criteria of 6 dB 10 millisecond. So we are, sorry, 6 dB. So we are in 6 dB. We have sounds coming from this array 6 dB louder from these arrays. We are still receiving some information from these arrays. This is not going to be this is not going to be high frequencies. This is mostly going to be low and low mids, and some of the mid-range coming from those arrays, but that information is actually useful. So that bleed from these arrays is useful, and that gives us a certain spatial perspective. So if we were to mute this system and leave only the outfield, that would be a pure mono sound, and that would sound as mono. But if we have this system unmuted, the frontal system unmuted, then in combination with the mono array, that will still create certain sense of space if properly designed and tuned. And if I unhide the stage, you can imagine that musicians will be on stage, and you will have something which is comparable to stereo in the sweet spot of sound. So you will have the information coming from this array, and you will have spatial information coming from these arrays. We don't show it on the metrics, but this is just from my experience from the gigs. Of course, we need to tune it properly for that. Then the next subject is we need to, what I will do is I will, for comparison purposes, I will hide the system and show you a conventional system which delivers the same or comparable SPL. We will compare the metrics and we will compare the price at the end. Let me go out of quality mapping. All these mappings and metrics I have saved in the Excel file, so I have prepared it for later on. So don't worry about remembering the numbers.
Sergey, real quick, before we go down this whole path, I think there's a bunch of questions we can answer that might make some sense. So if you want to look at your chat message real quick, then I'll start feeding the questions to you before we go down that path. So between Martin or Sergey, there's been a lot of questions about wider focus. Can either of you simplify like why we might choose wide, why we might choose focus? I think that's a really great question. Martin, you wanna jump on this one first, and then Sergey, I'll jump to you with the next question if we could.
Yeah, absolutely. So you've seen that the purpose of the focus design is to have to deliver the low-end capabilities to where it is really needed. So you could imagine, when you think about the first step to scale up things, that you would have to exchange all of your camera systems to K2 systems, but that might be quite expensive. And in the end, as Sergey told us, there's good reasons to put your low-end stuff in the middle. So why spend the budget on having it everywhere? And as Sergey also shown us, the level alignment and also the matching of the contour is as close as possible between the Cara and the K2 systems. So if you would take your Singer and pan it between this, that will actually make no difference. But if you would place your bass guitar in the left array, it would have not enough capability to handle it. So that's of course something the mixer has to know about, but naturally that's a way of choices that naturally comes from a mix, as we find it.
Right. So just logically or logistically mixing, we wouldn't ever get in a situation where we put the bass hard left and the drums hard right. And if I'm correct, the main reason of that is if you were to walk across the venue and you were, say, on the house left side next to the bass array, the bass would arrive, what, 30 milliseconds early? And that would cause a problem. So now we're keeping all of our low end in the middle because we have to organically from the mix. And so then we want all the low end and all those arrays to produce the low end that we need for that pop or rock. We just don't need it in those adjacent arrays, which helps us control the budget, which also helps us keep the coherence in the low end, and all of that works together. Is that right?
Exactly. That's the idea.
Perfect. And then the next question I've got, there's been a few questions obviously about what happens when, of course, we have all these arrays producing content as the low end narrow in the venue. And I think it's hard for people to understand that each array is doing a different thing, right? So they're not all doing the same thing.
Exactly. So the signal is, and it's in the hands of the mixing engineer. And this is what we talk about during our 3 days training. And there is a reason why this is a 3-day training, is that there is a lot to take on board. But basically, at the design stage, we assume that the signal is uncorrelated. Why we assume it? So uncorrelated signal means that all the objects sit in individual arrays. And it's in the hands of the mixing engineer if he chooses to creatively place the objects between the arrays, which is not necessarily a bad option. But we have the choice of whether we snap the sounds to the arrays and the signal between the arrays is completely uncorrelated, or we place the sound somewhere between. And between doesn't mean right in between, and where they would have the same level and they would create a typical comb filtering. It could be offset from the center. So we have level difference and we have partially correlated signal only on certain instruments as opposed to the entire mix.
Great. Cool. That's really great. And then I had another question, which is, I think, Martin, this might be right up your alley, and then we can maybe take a look at some stereo versus Elisa in terms of coverage, Sergey. I think that's the last thing you wanted to show, just to kind of highlight on that difference of the two systems. But Martin, someone was asking if my DJ is stereo, can we, obviously there's things we can do, but the reality is if we just have 1 or 2 channels of audio, there's not a whole lot we can do, right?
Exactly, yeah. So we have done some projects with DJs in immersive surround hyperreal sound, but the thing about it is you have to grab those DJs and tear them to your preparation studio, because there is a misunderstanding that the DJs get the information, you will have a great 3-dimensional sound system, and they show up with a USB stick and say, oh wow, this is great, can I play my tracks on it? This is of course not the way it is working, in the end you have to prepare stuff and think creatively to use that space that we give to you. And yeah, so that's basically the idea. So you have to set up a preparation space. You have to dedicate some time. You have to get the DJs into the idea of creating three-dimensional things. Look out for the elements that might work out for this. So yeah, and then it's fun. But otherwise, you're just setting up a great system with not having the right content. I mean, a lot of this is really about having the right content. So you don't have to set up a big extension system if you're just playing a jazz trio. Probably no sound that will go into the extension system, and it's the same for the DJ stuff.
Excellent. And then Sergey, I think the last thing you're going to show us was the coverage differences from that system in that arena in Eliza versus stereo. Is that correct?
Sure. I will, for now, what I will do is I will hide the frontal system. I will only unhide. This is just a reminder, this is the basic Eliza system, not including subs, just the frontal system. And the equivalent of that in terms of SPO would be this left and right system, which is, so the Eliza system, just for you to know, it was combination of K2 and Kara. I will unhide probably them side by side. No, it doesn't work. So just to give you an information, so these are three arrays of 12 K2 with 4 Kara underneath, 2 arrays of 20 Kara, and the equivalent system in the conventional world would be 12 plus 4 K 1 Kara combination. So this is quite typical size array for this kind of size of arena.
And so by equivalent, you're saying this has about the same amount of power for the audience, give or take. Is that right?
Exactly. And I will do quality mapping. If you remember, we were aiming for 105, and we were with the Eliza system, whichever option we go, whether we go for the synth system only, whether we combine it with extensions, we were always close to that number. So with synths plus extensions, we were just over 105. With 1 extension per side, with 2 extensions per side, we were 106. So with the conventional system, what I will do is I will unhide the entire system, combined with typical outfields or side arrays, so to speak. And I've also included the center array, because if you can, it's always good to have it here to cover the front area, which is never properly covered with so widely positioned left and right. And what I will do is I will do quality mapping. So quality mapping is not only useful for Eliza system. It's good to unmute the system, I suppose. Quality mapping gives us some good information even for conventional systems. Sorry for teasing you, but as soon as you attend the Eliza training, you will you will have this option, and you will be able to use it even in your conventional designs. So what we see in the quality mapping is that Eliza zone, currently there is no Eliza zone. This is why technically we don't call it Eliza zone, we call it shared aligned zone. So it's much smaller now. And let me just bring these metrics up here. So we can see that the SPO max average is 104.6, which is pretty close to the target. Even though it's a K1, it's only 2 arrays covering this area. So we have a PA system model, which is superior in terms of which is our flagship system, K1, but because there is only 2 arrays covering this area, we have 104.6. Pretty close to the target. We only have 27% of the Eliza zone. If we quickly go for the metrics, horizontal localization, and this is a this may look confusing that
So Sergey, if you go back to that last metric real quick,
Yep.
So let's just dive into this for people. So what this says is that bright green in the middle.
Yep.
If you were sitting there, you hear the sweet spot of stereo. Would that be like what we would call it? So I would get to hear anything in stereo sounds good there, and anything in dual mono sounds good there, right?
More or less, except
More or less,
our
so-
Ale and the
Sure,
comb
but
filtering and all of that.
If I'm in the middle there, I dual mono doesn't bother me. So that vocal at pan center, it still doesn't sound bad in those seats. and the guitar that's hard left and the sax that's hard right, I can totally perceive that. Now, if I go into the dark green area, I'm actually still hearing stereo over there. But of course, anything that's dual mono, I now have a huge time offset on that center vocal, which is causing a real disturbance in the clarity of that vocal. Would
exactly.
that be the way
all the main channels which are panned in the middle, they will all of a sudden, once you're here, they will snap to one side, and that's already quite boring considering.
And more importantly, we'll clearly hear two arrivals of all of those main channels. So kick, snare, hi-hat, lead guitar, lead vocal, piano, everything that's dual mono functionally, we hear two of at that location, which causes a degradation of the quality. And then it looks like if we go over into the outhang, there's a bit of overlap there, which then is, I guess, a fake stereo at that point, right? Or an alternate stereo or something along those lines.
Yeah, it's probably an interaction between the signal which is included here from both arrays and this array. But we all know how it works in the outfield area.
Good.
And we know that the panorama in the outfield area, if we can talk about this parameter, your involvement in the sound, your envelopment by the sound is much less in the outfield area, because mainly you will have the main bulk of sound coming from the outfield and the main left PA, which is giving you quite narrow panorama. Whereas in case of ELISA, you would still perceive a certain sense of panorama from the frontal system. So just quickly going through this, the horizontal localization, it may look confusing that it shows us good horizontal localization here, for instance. Remember that it is not actually, this is just giving us the error in terms of perception of where the sound is visually, where the sound source is visually on stage and where the sound is coming from. So if I'm here in the far field and there is a lead vocalist in the middle, even though there is no speaker above the lead vocalist, he's coming from here, the error in this dark green area is no more than 7.5 degrees. So in terms of the error, it's fine, but we know from experience that once we're in the dark green area, everything that is dual mono will snap here. So there is, as such, there is no horizontal localization at all in this area. But here, to avoid confusion, it is shown as a good horizontal localization, which is a bit misleading. This is probably the the limitation. It's a basic limitation. This is the error, but this is not to say that there is a good horizontal localization here. But the error is acceptable. It's no more than 7.5 degrees. Vertical localization with conventional systems is not as bad when compared to ELISA, because it's still fairly close. It's not as good, but it's not as bad. And panorama, when we look at the panorama, this is comparable to the ELISA system with no extensions. We can see the further away we go from the system, the smaller the panorama is. The closer we are, the better. We all know that when we go from the far areas of the venue towards the stage, we know that our envelopment by sound increases the closer we come to the system. So in terms of panorama, it's similar behavior, but no way in conventional system we can improve this panorama because this is defined by left and right. So this is the comparison. What I will do now is I will open the Excel file, which is the summary. So this is just the overview of what we are comparing. On the left-hand side, we will compare, I will zoom in a little bit. On the left side, I will compare, I will put the conventional left-right system. The next one, which is in the middle, is ELISA system with one pair of extensions. So one extension per side, and then on the right-hand side, ELISA system with two extensions. So this is just an overview of the system. I will zoom out a bit, and we will look at the comparison of ELISA zone. Obviously, there is no difference between these two systems with extensions. Whether you have one or two extensions, the ELISA zone is still the same. But when compared to the conventional, the ELISA zone is pretty small. In terms of SPO A-weighted comparable, the distribution is a bit different, but it's comparable. In terms of so the dark green area here is where you will have timing conflict here. So this is the dark green area in case of conventional system. This is where you have the same signal coming to you twice in case of dual mono sound objects. Resolution or discretization, this is just to show you that you have 2 pixels on the screen on the left hand side as opposed to 7 or 9 pixels. So we have much higher resolution with the ELISA. And just again, reminding you that by adding the extensions, we are improving panorama. That's the main reason. The other benefit is we are improving SPO, and the other benefit is we are increasing the resolution. What does it mean? It means that you will, by placing some objects, some sounds into the extensions, especially if there is 2, you free up even more space in your mix. So your mix is going to be even more transparent. You have more clarity of individual instruments. And then we will scroll down a bit. Yep.
So Sergey, when you take a scene system of 5 arrays, right? So we've got 5 across the front. That obviously, that increase in resolution means as a mixer, I can separate elements easier, right? I can use that space to hear things in more clarity, to have more space for it. By adding the extensions, we obviously gain resolution for certain types of musical elements. And that extra resolution gives us more clarity in our mix and more separation ability in our mix, which gives us more real estate to use.
Exactly.
So obviously more is better. So the bigger the number, the better it is. We always just have to be mindful that unfortunately we're not allowed to hang 37 arrays above the stage. So we have to find the balance between a good benefit and a great benefit. Is that correct?
Exactly. And this is where ELISA focus design comes handy. You can see that in addition to the difference in the low end, you have the difference in steps, and it's logarithmically increasing from the center towards the out. So we need to be rational. So we cannot just maintain the same step. We are trying to be realistic in terms of budget, in terms of rigging constraints and everything. So the steps is increasing. But typically, if you think about it, in your mix, more rhythmic elements will be in the middle, and they will be the elements which are typically going to extensions are less defined in time. They are paths and reverberation. So we can afford to increase the step as we go out from the system. So the next parameter comparison is horizontal localization between the 3 systems. Obviously, there is no difference between the 7 or 9 array system, but you can see that the percentage here is much smaller. Vertical localization is similar, but still better with the ELISA system. And last is panorama. So panorama is significantly better in case of 7 arrays compared to conventional system. And if we add 2 more arrays, so if you have 9 arrays, we have more than 70% of the ELISA zone with panorama greater than 40 degrees. Last but not least is the budget comparison. So if we were to compare the systems based on the price, on the purchase price, which is reflected in the rental price to an extent, or it is directly linked, then if we say that the system on the left is 100 units, then the system in the middle would be 20% more expensive, and the system on the right-hand side would be 36% more expensive than the conventional system. So this is to, let me just go back to sound vision. This is to highlight, to emphasize that system is not several times more expensive. It's fractionally more expensive. So what we are typically aiming for is, with frontal systems at least, is to stay within 40% of budget increase. Of course, we are not including the potential extra costs which would result from the extra rigging arrangements, or maybe from the extra 2 crew members. So if you would to have, say, 2 or 3 people on the tour, on the arena tour as an audio crew, 2 or 3 people with a ELISA system, 4 people would be necessary. That's what they had during the Mark Knopfler tour. They had 4 audio crew. So you will have 1 or 2 extra persons. But we are not talking about increase of 100%, or we are not talking about increase of 2 or 3 times more expensive. And then when we talk about the budget, audio is only a fraction of the overall budget.
So so what you're saying here is, obviously, let's say we go from 2 stereo arrays to all of a sudden 7. So one might think that it's 3.5 times more expensive. Oh my gosh, that's a huge increase. But what we're actually doing is, opposed to each of these arrays having a huge amount of power, they all have a bit less. So that means less speakers, less weight, less amplification, but we have more arrays. So the total budget goes up, but not by 3 times or 2 times. It goes up by 20 or 30%, relatively speaking, on that aspect of it in comparison. And if I'm correct, Martin, maybe you can confirm this for me, in a wide design comparison to a stereo system, say in a performing arts center type project, it's sometimes even pretty comparable between a Lisa and stereo. Is that about right?
Yeah, that's right, because you don't have, I mean, you would, with a wide design, you would place the same sources that you would have as with a conventional design. So you would have no need to bring in like something larger, and that's pretty close, I guess.
Great. And I think the last question, I saw this come up a few times, and maybe you can just quickly answer it, Sergey or Martin. The alignment of the fills, how do we, okay, I've got all these front fills, where do I time align them to? What is my reference point?
Well, the logical reference point is the center of the system, because this is a good medium, good compromise between going left and right. So if you imagine you're here, we would align the outfill or the side array, whatever your terminology is for that, we would align it to the center array. And of course, the position of the outfill is crucial in many ways. So when you define the position, that will affect your time alignment as well. And then the best position would be the position which gives you enough coverage, which also gives you enough coverage from the outfill, which does not interfere too much with the coverage of the main array, but also the azimuth angle. The position and the azimuth angle will affect the coverage. The position should also work well with the imaging, so where it is in relation to the stage and how it's going to interact with the main system, but also the best position will give you the least disruptive timing relationship between the outfill and other arrays. And on the controller side, if you think that what would be the timing like with this array and this, I don't know if we will mention it during tomorrow's seminar, but I will touch it on. We can scope out how much we include into the mono mix down, so we can actually reduce the contribution of these arrays of the sounds placed to the outer extremes of the system. They do not necessarily have to go into the outfield because they're already quite close to this array. So we can control the amount of energy going here. But going back to the original question, timing is done in relation to the center array.
Cool. Thank you, Sergey. And I'm going to give, I think, Martin the last word here today. And this question's come up. You guys have both touched on it briefly, but man, you guys have some really cool tools in sound vision. How do I get those? You want to give the several $100 answer?
Yeah, well, if you give me the several $100, it's fine for me. So the answer to that is very easy. Just come and join our ELISA trainings. So we have a training program, which is a 3-day training program on ELISA topics. So it's including some of the mixing tools, and depending on if you're a system guy or a mixing guy, it will be focused a bit more on both sides, but it will include for everybody the full idea. And if you have done this 3-day training on the system track, where we have a full afternoon about sound vision design, then we will unlock this feature pack for you.
I guess the answer is easy, but it's not easy to do during the lockdown. And of course, we cannot do it, even if we wanted, we cannot do it over the internet, because the training involves some practical experience and certain equipment. But as soon as you have chance, as soon as we are back to normal, make sure you try and get to one of those as quickly as possible.
I think there's light at the end of the tunnel, so
There should be.
see you there.
I can see it
Excellent.
in your window.
Excellent. Sergey, Martin, I always appreciate spending time with you guys. It's been a great experience learning a bit more about how we do sound design in ELISA. It's obviously a hugely complex conversation that is hard to summarize in an hour or an hour and a half. But please, I invite everyone to join us the rest of the week. Tomorrow, we're going to talk about how to create and mix in ELISA. And on Friday, we have a great conversation with a couple of real professionals who've been using ELISA for years. Thank you, everyone, for joining us. Thank you for coming today. Don't hesitate to reach out to us on social media. Check out our videos on YouTube. We've got a bunch of great things coming in the future, and that schedule will be announced soon. So thank you, everyone, very much. Have a great rest of your day. Martin, as always, thank you. Sergey, as always, thank you. Tommy, Marcus, Arno, thanks for the help in the moderation. We'll talk to you guys soon. Cheers.
Thanks, everybody. Thanks for joining us.